Okay, in this video we're going to go over one of the handiest features that the ProAFI has, and that's the override mode. Pseudo RPM, pseudo mode is another name that it's known by. But what this mode allows us to do is put the software and the ECU in a simulated engine running function to where you can test all the ancillary devices and to make sure they're working properly. You can scope outputs, things like that, very easily doing it this way. But the thing we want to be careful of is when it's connected to a live engine, we want to make sure that we take some certain precautions so we don't cause any damage to anything. So the first thing we're going to do is go into the setup. You can do that by also hitting F1. And go over to the overrides tab. And then you're going to see some parameters over here showing what's going on with the engine. You've got your fuel map over here so you can simulate certain things running. I'll get to that in a minute. And then we've got our override functions over here for standard sensor inputs. So first things first, when we run it in override mode, it is going to run as if it's getting an engine RPM. So if I type in 500 here, it's going to think the engine's running at 500 RPM. So it's going to be running your fuel pump, it's going to be running your injectors and coils. So since the engine's not spinning over, we want to take certain precautions so we don't flood the engine with fuel, start blowing up intake manifolds because the intake valve's open and we turn on a spark event with fuel in there, things like that. So the first thing we want to do is come in here and disable our fuel pump. So we're going to set that to override, and 0 override is off. A 1 would be on. So if I wanted to test the fuel pump circuit, for example, I could override it and set it to a 1, and your pump will start running. But for this case, we're going to go ahead and set it to 0. And then in V5 and later softwares, or firmwares, excuse me, we have the functionality to disable all injectors with one keystroke. On previous versions, you have to go and disable them individually. Now, if you're testing your injectors, you may want to disable, individually, and then come back and turn one on at a time and make sure that you can hear that injector cycling. So these enable functions would be good for testing the injectors. But let's say we want to test our coils. We're going to disable all the injectors, leave the coils enabled, and then I'm going to come up here and I'm going to put it into a pseudo mode, and I'm going to type in, say we lay all the coils out on the valve cover and we know the firing order and we want to run it at a really low speed, and we can watch it go through the firing order to make sure that it's firing. We've wired it correctly and it's firing the way we want. So we can type in 100 and you're going to get a very low pulse, going through each one of the firing orders, and you can physically watch where it's firing. Then if I wanted to check, maybe we've got a misfire happening at 6,000 RPM on the dyno at 15 pounds of boost or whatever, we can type in all those parameters here. So we'd go up here and we'd type in 6,000, and then I've got 15 entered here, so let's leave it at that. We'll put that at override. So now we're getting fueling for 15 pounds of boost. Throttle at 100 and override. Coolant temp, maybe we're running at 180 degrees F, and then we're going to override that one. And then fuel mixture, if we want to change our commanded, we could do it here. We don't have to. It'll automatically pull our commanded right out of here. And then we've got, our actual. If we want to keep from getting faults and things like that, we would want to type that in here. So down here we've got our AFR is 10.6. So we can override that, maybe make that 14, whatever we want. So the idea is that we're simulating accurate pulse widths where the problem's happening, and accurate ignition events and dwell times and things like that. And then you can physically come back in and listen for an injector that may not be firing at a given frequency. We've run into that a lot where, maybe the miss is happening at 6,000 RPM and this given pulse width is running the injector at a duty cycle where there's a problem with the injector and it doesn't want to consistently run, so you can hear it actually not cycling the same frequency as the other injectors are. So you can track down problems that way. Actual advance probably isn't going to do you a lot of good when you're checking it in pseudo mode, but you can override the ignition advance, what temperature you're running at. Again, we're trying to, as accurately as possible, emulate where the problem is happening. So by putting all these overrides at the same exact point that you're having them happen, you're going to put all your ancillary devices in that functionality as well, and then it can help you track down that problem. Again, you can override fuel pressure and make sure that that's all working correctly, again, to get us the right pulse width. So maybe we're at 58 pounds of fuel pressure, something like that. So we're going to override those. And so you can see now we've got 19.7 milliseconds down here. and it's putting us at that point in the map. So if I wanted to raise or lower that, or do anything you want to, one thing that we've done is a lot of people switching from other systems go to ProAFI to take advantage of all the other things that we've got, traction control and the accuracy of timing and things like that. They have data from their old computer, which may not necessarily apply to this. But one thing that you can start with is figuring out if you know what pulse width you were running with the same fuel system. You can write those numbers down and given RPM points, and then you can adjust these values up or down to get you to the pulse width that you need to be that you were making before. So it can be handy for setting that up. I've done a lot of maps from scratch, when people were converting from other systems, that we've dropped right in and put them on the dyno, and the car just runs. So this tool is very, very powerful. The other section that you can get to overrides for different stuff is in your I/O. This one you can do specific outputs. So you can just say, okay, I want to test my AC clutch, override it, and go click, 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 make sure your AC compressor clutch is engaging and disengaging to make sure that wiring's correct or that it's functioning correct. If your AC is not working, you can do a quick test to make sure it's not the compressor. Your solenoids, you can override those to make sure those are wired correctly. Same with all your fuel pumps, your nitro stage solenoids. Cycle those one at a time to check your wiring, driver's indicator light, everything right here you can override and check without physically running it on the engine saying, wow, I hope I wired that right and I hope it turns on when it's supposed to. So at least if you know that your wiring and the functionality is set up correctly and everything's assigned correctly in the pins, that everything's going to work the way it's supposed to. So yeah, these overrides, it's a very handy thing. A lot of the tech calls that we get could really quickly be solved by checking these things in override. They'll allow you to be able to discern if your engine's not starting, for example. If you put it in an override and all the ancillary functions are working, then that narrows it down to being a problem with the camera crank input. A lot of times people aren't real familiar with how to look at the cam and crank inputs and when you're getting errors there, so this is real handy to test some of that stuff as well.